So now we're going to take a look at some of the basics of some statistical concepts. And specifically, we're going to focus a little bit on some continuous data. So one of the main concepts that we have is called this measure of central tendency. Now, it's pretty much as this term suggests. Central tendency means the tendency of a set of data to fall around a certain point. So we have a couple of measures. One is the mean, another one is the median, and another one is the mode. And we'll have some descriptions of the data set as well, which will include percentiles and quartiles, which will be related to some of these measures of central tendency. And that's really important because as we understand where the data tries to aggregate towards, we will also understand the variability around that or the variance around that. So it becomes important to understand these measures of central tendency in terms of describing the data that we have. The first one we've got is the mean. Now, we pretty much know what the mean is because this is just our average. And it's the most commonly used measure of central tendency. So if we have a number of grades for a class, it's generally accepted that students will say, well, what was the average? And why do they do that? They say the reason they ask, well, what was the average is because they want to know where their score lies in terms of the average. Did they do better than the rest of the class, or did they do worse than the rest of the class? So it's used as a gauge to describe the entire data set or set of students who took the actual exam. Now, a sample mean is derived basically very simply by adding up all of the individual observations and dividing by n. And we know this from some basic math from our younger days, I'm certain. But we have some specific terms here. What you'll see this notation called x bar. So it's an x with a line over it. So we denote that as x bar. And that's usually referred to as the sample mean. So given the fact that we take a subset of data, we will actually calculate its average, and that average is now called the sample mean. And this formula here basically says, let's just sum up all of the individual observations, those are denoted by xi, and we'll divide by n. Now, again, it should be noted that the sample mean is x bar, like we said, but we also have a population mean. And a population mean would be what is the average for everyone that exists in a particular population. And this might be, let's say, human beings, what is the average temperature? And the average temperature for human beings would be 98.6. So we would denote any population parameters with a Greek letter, but we will note any sample type of parameters, like the sample mean, with Latin letters. So you'll see things such as mu and sigma, and the mu and sigma will correspond to the population mean and the population variance. And the corresponding sample mean and sample variance would be denoted as x bar and the letter s. In Excel, we'll use the function average to calculate the average or the mean of a data set. Now, another measure of central tendency is the median. And the median basically corresponds to the middle of the data. So if you think median, middle, it'll be a little alliteration there for you. So given a set of numbers here in this one set, the first thing we'll need to do is we'll need to order the set. So that should be fairly simple. Since we have 9 numbers, we're going to take the fifth number, which in this case is the number 4. So you'll see you have 1, 1, 2, 3, then a 4, then 4, 4, 5, 11 in that set. So 4 would be our median. Now, in the case that we have even set of numbers, we'll take the middle 2 numbers, which in this case, in this new set, we've added a slight change where we have 1, 1, 2, 3, 4, 5, 8, 9, 11, 12. So the 2 middle numbers are 4 and 5, and we'll basically take the average of those 2 numbers, which would be 4.5. In Excel, you can use the function median of the data set, which will provide the median of the data set. Now, the median itself has very good properties, especially when the data is not normally distributed and you don't have that bell curve. So consider the fact that there are certain distributions or there are certain data sets that don't have a normal bell curve, and the median is actually a very good approximation there of a measure of central tendency for those types of distributions. In fact, if you do have a bell curve, the median and the mean will actually be very close or identical. Now, the mode is another measure of central tendency, and what we're doing is we're looking at the most common or most frequent number that appears in the data set. So given this set of numbers that we have, 1, 4, 5, 3, 4, 11, 4, and 1, it's obvious to see that the most frequent number is 4. If 2 numbers appear the most times in a set, such as 4 and 1 in this case, both of those numbers are bimodal. Both of those numbers are modes, and in this case we call this bimodal. If we have more than 2 modes, then this is called multimodal. In Excel, we have the function mode, which will provide the mode of a data set. So the mode isn't very exciting, but it does provide some interesting insights, especially into some large data sets, and there are some general uses for it. But for the most part, median and mean will be the 2 biggest central measures of tendency that we will focus on. Now, in terms of quartiles are useful because they help us split the data set to understand the distribution, and they split it evenly. And as quartiles suggest, we're going to be splitting it into 4 pieces. The first quartile is basically going to correspond to the lowest 25% of the data. The second quartile will refer to the second lowest 25% of the data, which would be just below the median. Remember that the median splits the data in half, so you'll have 50% of the data above and below the median. So the second quartile would basically be the quartile that's just below the median. And so the first and second quartile will be both the 50% below the median. The third quartile will be the third 25% just above the median, and the fourth quartile will be the highest 25%. Now, if we take a look graphically on the quartiles, again, remember our box plot chart, the box and whisker plot chart that we had, and we could see that this is how the box and whisker plot refers to the quartiles. The bottom one would be Q1, and the top one would be Q4, and these are your whiskers, if you will. The center area, the center box of the second and third quartile, which are split by that dark middle line, which is the median, represents what's called the interquartile range. So the interquartile range will show us the second and third quartiles together. It's also important to note that the quartiles do not have to be the same size, and they generally won't be. You may have, as we had seen in the previous example, one whisker being very tall, another whisker being very short, and even the median might look like it's higher against one of the quartiles, the third quartile, as opposed to the second quartile. Now, percentiles are pretty much the same as quartiles. The only difference is quartiles, there are 4 quartiles, but recall that the quartiles were representing 25%, 50%, 75% of the data. Well, those are really percentiles. The 25th percentile would be 25% of the data falling below a particular point. So we can actually use the 25th percentile to give us the same value as our quartile. And we may want to know who's in the bottom third. So we will look at the 33rd percentile. And if we want to know what's below the 72nd percentile, we can determine the percentile of the 72.72 to figure out what that point is below the 72nd percentile. And we might use this to compare certain values. So if we say someone was in the highest percentile, let's say the highest 10%, we might find the 90th percentile and say that everybody below that point is below the 90th percentile and everybody above is in the top 10%. So how do we use percentiles and quartiles in Excel? In Excel, we're going to use the quartile function and the percentile function. So the first parameter will be to give it the data, and then in the case of quartile, we'll choose whether we're going to choose the first quartile, second quartile, third quartile, or fourth quartile. If we use percentile, we're going to do the same thing with percentile where we provide the data, and then we'll provide the percentage that we're going to use. So in this case, in the example below, 0.33, 0.72, and 0.50. And you can see that the percentile, the 50th percentile, is identical as the median. For the purposes of these examples, note that the data will refer to the actual data set or the range of the data set in Excel.